Alright, I wanted to spend some time graphing the sine curve and then a couple of different transformations. So we give something just generic, f of x equals a times sine of k times x minus b plus k. This is just kind of the generic form for a sine function. A is called the amplitude, and we always refer to the absolute value. If it's negative, that just causes it to reflect over the x-axis. The period is always going to be what 2 pi over k, and the sine function repeats itself every 2 pi. So if we have this factor of k here, it's going to either accelerate or slow down the whole cycle, depending on if it's greater than 1 or between 0 and 1. B is called the phase shift, so it's your horizontal shift left or right, and then K is your vertical shift up or down. Okay, so we're going to start off with just not vertical shift B, vertical shift K. We're going to start off with graphing just the good old sine curve. Okay, and we use a 5-point method, and the points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And these correspond to the east, north, west, and south poles. Those are the easy ones to do on the unit circle. You can certainly do some of the other nice angles too to kind of get a better feel for the curve, but this is the 5-point method. And that corresponds to 0, 1, 0, negative 1, and 0, and that's always going to be the case for the sine. Of course, things are going to be shifted around, stretched, and that kind of jazz when we graph some other more interesting sine functions. I'm going to draw just the poles over here. So we have 0 and 2 pi, then pi over 2, and pi, 3 pi over 2, and the coordinates are 0, 1, sorry, I said it backwards, 1, 0, and then 0, 1, and then minus 1, 0, and then 0, negative 1. So the sine is the y-coordinates. So our y-coordinates go 0, 1, 0, negative 1, 0, which corresponds to our table we have over here. Oops. Alright, so we'll graph our xy plane, put in our x coordinates, and then put in our y coordinates, and then we'll go ahead and graph our curve, applying our points. So I'm always going to have this kind of a concave down type of shape here, concave up shape here, and then the process continues. We're going to have a concave up over here. I'm sorry, that's concave down. Concave up, concave down, and then we're going to have a concave up over here. So the sine curve is going to repeat itself every 2 pi. Now the concavity, we won't really have a formal way of finding it really until you get into calculus and using the second derivative. Anyway, so that's your sine curve. It's going to continue on in either direction infinitely. So I'll put in one more point. So negative pi over 2 corresponds, oops, well, let's go back here. Negative pi over 2 is the same thing as 3 pi over 2. Okay, so let's do another one, a little bit more stuff going on with it. So we're going to graph y equals 2 sine of, I think it's a 3x. Our amplitude is 2, and the sine curve repeats itself every 2 pi, so the argument is 3x, so we're going to squeeze that in there. Your k is going to be 3, so your period is going to be 2 pi over 3, so we divide all 3 sides of the inequality by 3 to isolate that x, so 0 divided by 3 is just 0, 2 pi divided by 3 is 2 pi over 3, and the 2 pi over 3 is going to be your period, so that's how long it takes for this particular graph to repeat itself. Okay. Now what I do for the 5-point method is I'm going to still use the 0, the pi over 2, the pi, the 3 pi over 2, and the 2 pi. However, my argument is no longer x, it's 3x. So what I'm going to do is I'm just going to solve for x. X equals 0, x equals pi over 2, x equals pi, x equals 3 pi over 2, and 2 pi. And that'll make it fairly easy. So we're going to go ahead and set 3x equal to each one of these. 3x is the argument. And to solve for x for each one of those, I'm going to have to divide by 3. So 0 divided by 3 is 3. Pi over 2 divided by 3 is pi over 6. Pi divided by 3 is pi over 3. 3 pi over 2 divided by 3 is pi over 2. And 2 pi over 3. Okay. Notice I started at 0 and ended at 2 pi over 3. Notice over here on my table I start at 0 and end at 2 pi over 3. Okay. So these are my translations. Okay. So we start at 0 and we are increasing by pi over 6. So how I get that pi over 6 is I want to divide up this interval of length 2 pi over 3 and 0, and I want to divide that by 4. I want to put it into 4 equal pieces. So what's going to happen here is 4 is going to go into 2 once, and then we have a 2 left over. So then the 3 times 2 gives me 6 over pi. So it's always, we're dividing it into four intervals, so we divide by 4, so we need to take the difference of the start and ending location and divide that by 4, so we're increasing by pi over 6 each time. Alright, so now it's going to work the same way. I'm just going to go 1, 0, negative 1, 0, and 1. Okay, so these particular values we found are going to translate into the poles. However, since we are our amplitude is 2, it's just going to double everything. Okay, so double 0 is 0, double 1 is 2, etc. Okay. So we'll go ahead and make our xy plane. We know that we're increasing by pi over 6. We're starting at 0, so we're going to put that information in. Pi over 6, pi over 3, pi over 2, and 2 pi over 3. Okay, and then we'll just plot our points. Okay, so there's my concave down part, my concave up part, and there is my figure. If I wanted to continue, this would head down this way, this would head up this way, and we can continue our curve forever in either direction. I would just need to keep adding pi over 6 or subtracting pi over 6, and this pattern would continue. I'm going to do one more example with you. This one's a little bit more advanced. It's got a few more things. We kind of throw everything at you, so there's going to be quite a bunch of stuff going on, and we just have to focus on the individual pieces. Don't try to take it all in at the same time. So we have y equals y equals 3x minus pi over 2 plus 1. So my amplitude is going to be the absolute value of that negative 2, so it's going to be positive 2. What the negative does is going to reflect it over the x-axis, and I end up writing that a little bit later. The plus 1 at the end there, that's my vertical shift, so it's going to move everybody up 1 unit. Okay. Now, in order to find what the phase shift is, it needs to be in the form x minus or x plus. Right now it's in the form 3x minus pi over 2. So what we need to do is we need to factor out a 3. So what happens is then we have x and then minus pi over 2, and I need to compensate for this. So if I'm multiplying by 3 on the outside, I need to divide everybody by 3 on the inside, so it's still the same thing. Well, multiplying by a third is the same thing as dividing by 3. So what I'm going to end up getting is x minus pi over 6 inside there when I factor that 3 out. So it's a nice little trick so we can actually see what the phase shift is, because it needs to be in that form x minus, not 3x minus. Okay, so that becomes x minus pi over 6 and then plus 1. Now we can say that our phase shift is to the right pi over 6. Okay, my k is the 3. My k is the 3, so like the last one, my period's going to be 2 pi over k, so this will be 2 pi over 3. Now I'm writing down there just a reflection over the x-axis. I mentioned it earlier, I didn't write it down right away. Notice how I'm just kind of piecing each thing together. Okay, what's the negative 2 do? What's that plus 1 at the end do? Okay, now we need to get it in the form k times x minus b so I can find the phase shift. Now what I'm doing is the argument inside the sine is 3 and then times the quantity x minus pi over 6. Now sine does its thing between 0 and 2 pi, so I'm going to set that in between. And this will help me find my starting and ending locations. So the first thing I do is I divide by 3. So 0 divided by 3 is still 0. And then 2 pi divided by 3 is 2 pi over 3. Okay. And then I'm going to add pi over 6 to all 3 sides of the inequality. First I'm going to mention that my period is 2 pi over 3. So when I add pi over 6 to 0, I get pi over 6, x in the middle, and 5 pi over 6. So I had to find a common denominator. So we have 2 pi over 3 is the same thing as 4 pi over 6, and then when I add another pi over 6, that's where I get that 5 pi over 6. And then I'm writing underneath the pi over 6 and the 5 pi over 6. That's my start and my end. Start or finish, whatever you want to call it. Alright, so we're going to do the same game as we did before. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And each one of these I'm going to set equal to those things, the argument right here, I'm going to set equal to it. I'm going to solve for x for each one. So x and y. Okay, so our start was pi over 6, and our end was 5 pi over 6. Now if I want to, and I think I mentioned this again later, is if you want to figure out how much you're increasing by, we do 5 pi over 6. That's our finish and our start. And then we divide that by 4. So what I would have is 4 pi over 6 and then divide by 4. All the 4's are going to cancel and I'm going to have pi over 6. Coincidence, well, sort of coincidence that it was similar to what it was the last time. So we're going to increase by pi over 6. That's an alternative way of doing this. I would just be adding pi over 6. So pi over 6 plus pi over 6 is 2 pi over 6, which reduces to pi thirds. And then plus another pi over 6 will give me 4 pi over 6. Did I say that correctly? Let me double check to make sure I said that correctly. No, I did not say that correctly. So we're right here. Here's the pi over 3 is pi over 6 plus pi over 6. It's 2 pi over 6, which reduces to pi thirds. Okay, and then to get to the next one, we have 2 pi over 6 plus pi over 6 would be 3 pi over 6, which gives me the pi over 2. And then 3 pi over 6 plus another pi over 6 gives me 4 pi over 6, which will make this 2 pi over 3. Sorry about that. Okay, now, here again, I'm mentioning how I find dividing by, or adding pi over 6. we're going to divide that into 4 equal pieces, so it's the end minus the start divided by 4. Okay. Now, how I'm going to come up with these numbers here is it's going to follow the same thing. It's the sine, so it goes 0, 1, 0, -1, and then 0. However, because I have an amplitude of -2 and then a vertical shift of 1, that's going to do -2 times 0 plus 1 is 1. -2 times 1 is -2 plus 1, be -1. This one be 1. -2 times -1 be +2 plus 1 is 3, and then the 0 will give me that 1 again. So that's where these numbers are coming from. So it's a lot of arithmetic. Okay, and we will graph this just like we did before, x and y axis, putting in our points that we're plotting on the x-axis, and then our amplitude is 2, so we need to go at least up 2 units. Well, not at least. We need to, so our amplitude is 2, our vertical shift is 1, so we need to go at least 2 up from 1, which would be 3, and then down 2 from 1, which would be -1. So that's going to be the range, -1 to 3. Okay, and we'll plot our points. And concave up, concave down. And then that graph is going to continue doing its thing. Label your x and your y axis. This is probably close to about as complicated as they get. So just focus on the individual pieces. What's the amplitude doing? Is it reflection? Okay, do I have a horizontal shift? What is it? And then I need to figure out what the phase shift is, so I need to get it in the form k times x minus b. Then that'll tell me the phase shift, where I'm moving left or right. Then I'm going to take the argument inside the sine or the cosine. So the sine and the cosine, if you can do sine, then you can do cosine. And you put that argument in between 0 and 2 pi, because that's the period of the sine and the cosine. And then you'll solve for the x inside the argument in between 0 and 2 pi. 2 pi over the k is going to be your period. The left side, after you're all done solving the thing, is going to be your start. The right side will be your end. Then you take the difference of your endpoints and divide it by 4, and that'll tell you how much you're increasing by. Alternatively, you can just set the argument equal to our 5 points, the 0, the pi over 2, the pi, the 3 pi over 2, and the 2 pi. And it just takes a little bit of practice, and that's why there's quite a few homework problems just to go through this process. And it's kind of fun too.